All right, so section 2, we're still looking at categorical data, but now we're going to look at comparing, basically looking at a relationship between two categorical variables simultaneously. So you can imagine that one split bar chart we saw where it had black or white defendants and what plea deal they received. The original data set probably looked something like this, right? We had defendant number 1, and then we had whether they were black or white, and then what type of deal they had. So maybe this person had a fine. And then we had defendant number 2, and maybe this person got time served. So forth and so on. And the one thing we kind of lost in looking at that particular graph, right, is it didn't say how many people fell into both groups. We don't know how large those sample sizes were, whether they were comparable in terms of the actual size. When we looked at the one that college completion and gender and race, that one actually put down the sample sizes so we could see we were looking at, hundreds of thousands of students in some of those subcategories, right? But anyways, this is what our data would look like. And the graphs, that split bar chart and that stack bar chart, were really useful, but they're kind of a further step along the way. So we couldn't just do a frequency table, we saw in the last one, because a frequency table would just give us the breakdown of black and white and then what type of plea they got. So maybe it was that jail versus, I don't remember all of them off the top of my head, jail, a fine, time served, and we would just have the number. So we could look at that actual article or wherever that had come from, and when I find this is maybe 500 and say this is 500. I know that's not the case, but this doesn't really help us break down and make that split bar chart. So that's where we need what we have next, which is our contingency table. Our contingency table allows us to categorize both of those variables at once. You'll sometimes see these contingency tables called a 2x2 table. But that's only when we have binary variables for both of our categoricals. So contingency table is more inclusive, but you will sometimes see this instead. So if we were thinking about our plea deal question, you'd probably have something like this. We'd have black and white defendants, and then you'd have all the different things that could happen. And then you'd have the count of how many people fell into each of these groups. So maybe 250, maybe 100, whatever it might be. So then you could actually make that split bar chart we saw. So that's our contingency table. We will make this one here, sorting our class out by gender and major. But I need that data first. So that's why I have that link to the StatCrunch survey at the beginning. And we'll just jump down to our other types of contingency tables really quickly. So there are two other ways that we can do our contingency table. Again, I'm going to use that made up data of okay, what if we were looking at our black and white defendants, and what if we were looking at the different plea deals they received? Well, if we did something like this, by the way, we could then have a total category for everything like we did in that's a 250, so 350, and then a total category here as well. And this would be all the different things that happened to those black defendants. And so let's just pretend it's 500 and 500. So one way we could do this is that we could make this into joint proportions or relative frequencies instead. And relative frequencies are exactly what we saw in the frequency tables. I could just take everything here and divide it by 1,000. So instead of saying 25, we could say 25%. Instead of saying 100, we could say 10% or 0.1. As we saw in the frequency tables, this is basically very similar to what we saw in the actual split bar chart, in that we don't know how many defendants there were, right? We have no idea what that sample size is. We needed to read the article to find it because they never put it in there, unlike that split bar chart. So that would be a relative frequency. It's just everybody is a percent of the total number. What we saw in the split bar chart, and is usually true in a lot of the stacked bar charts, sorry, I've got to bring everything back, is that these are given as conditional proportions. So in this case, if you looked at that thing, so hold on, let me just bring it back really quick. If we look at this data, like I said, it doesn't tell us how many. We just have the percent of plea offer deals, and we got percentages here. If you added up all of these, you're going to get 100%. I hope to God. I did not bother to do it. And if you add up all these, you'll get 100%. So if there were the exact same number of white and black defendants, great, but we don't know that, right? All we know is that of the black defendants, 74% were offered jail or prison time as their plea. So this is what we call a conditional frequency. And in this case, we would have been conditioning on the actual race, right? So of these 500 people, and let's go ahead and in this example pretend that we didn't have the same numbers. Let's pretend this was 400 and that this was 600, just so we could see how we could use these conditionals to compare apples and oranges. So if this was the case and we had 250 in this group, that doesn't work for our little split bar chart. But what we would do is we would take and we'd say, okay, of the defendants who we identified as black, 250 of those 600 got jail time, whereas 100 of the 400 white defendants were offered jail time. And so then we can kind of compare them and look at the percents within each group. So if the next one was the fine, we'd do the same things. We'd say, oh, maybe 10 of our 600 black defendants versus 100 of our, I'm just making up crazy numbers. But you get the idea, hopefully, is that we're saying, okay, within these groups, what is the percentage? So that we can make basically that split bar chart or the stacked bar chart we saw in the next one. So that's a conditional table. That's super useful, especially if we're doing the split or the stacked bar charts. And I'll probably make one in class just so we can kind of see the difference. Actually, let me really quickly pull one up. So I'm going to try to show you why that is so important. Here we have responses to my spring survey. And we're going to choose something that isn't very even, right? I think in terms of birthplace, let me just quickly look. I'll do a bar plot of birthplace. I'm pretty sure this is pretty uneven. Yes, we have a lot more students who are born in San Diego than anywhere else. California is next. US is, and then we have the smallest number of international students. So if we're going to do that, let's say we're interested in how does the different places people are born influence what class they end up taking. So if I did a graph, again, I could do my bar plot. And let's say I wanted to look at what class people are in, and I wanted to group it by, I always choose the wrong one. So we'll see if I do this right. Birthplace. And I'm doing a split bar chart. You can see right now the type is frequency. So what happens is I get this plot. This is not what I wanted. It's the opposite. Let me flip them. I always do it this way. So, oh, I didn't say gender. I wanted class. All right, so this makes it a lot harder to kind of see what's going on. It's not terrible because we can see already we have bigger, the taller purple bars, more students in Thursday who are from San Diego and from California. And then if you look at these international and outside of the US, but outside of California, those green bars are much larger. So we have a lot more students who are international and, you know, like people who've moved here to San Diego who were in my Tuesday class. Interesting. I honestly am surprised by the results of this, but it is kind of hard to see. So that's why one of the things you might want to do is do what we talked about here of that sort of conditional. Unfortunately, you can't see it, but then next we can do relative frequency. That's just going to give us percent, so the graph will look exactly the same. But now on the side, instead of having the number of people, it has a decimal version, but it's the exact same graph. If I change this up and make it percents, it's going to be the exact same graph, but that y-axis is just going to change again to be percents. So the last one that you can't see here, let me pull up this screen and do this again, is relative frequency or percent within the category. So this is going to put everybody so that all the groups are the same percentage. So 100% of all the people from the US, where did they end up? And if I do this, now all the bars, if you added them together, like you put these on top of each other, would be exactly the same size. So we can see this huge percent, or huge, over 80%, almost 90% of the students from outside the US were in my Tuesday class. You could even, this to me, we talked about this in class, but I think it's more useful to see this as a stacked bar chart, personally, because then we can really see, oh goodness, now they're all out of 100, and we can see just how huge this is. So we're trying to think of like, why would this happen? And the Tuesday class did fill up first because it was first on the schedule. They were both hybrid. So perhaps the international students have an earlier registration date, or maybe they're just more on top of it in terms of registering. But this is the idea of a relative, of a conditional percentage as opposed to a relative percentage. And then last piece here I could show you is we could even do a contingency table here. And within the contingency table, you have the same options. So if I wanted to look at what class people are in by their birthplace, I could sit and say, okay, well, I could have it display row percents or column percents. So if I wanted to look within the birthplaces, I'm doing column percents. And now it's not only giving me the number of people who fall into each category, but it's telling me the percent of everyone outside the US. 90% were in Tuesday. Everyone from San Diego, 56% were in Thursday. So lots of cool stuff you can do to sort of look at and describe two variables at once.